Hello everyone and welcome back to my channel. In today's video, we will explore the theory of cross-site request forgery and apply our knowledge by solving the Portswigger Lab titled CSRF where token validation depends on request method. To achieve this, we will use a tool called CSRF POC Generator, which is provided in Burp Suite Professional. Alright, let's jump right in. Alright guys, so what is cross-site request forgery, or CSRF in short? Well, CSRF is an attack that forces an end user to execute unwanted actions on a web application in which they are currently logged in. To further clarify, picture this. A hacker is crafting a malicious link targeting users that are logged into a vulnerable website. Meanwhile, the victim is logged into the vulnerable website and going about her usual activities. Out of nowhere, she receives a seemingly harmless link, and without suspecting anything, she clicks on it. In an instant, the hacker seizes control by changing the victim's email address to his own, effectively taking over the victim's account. So as you probably already guessed, the impact of this attack can be very serious as it causes the victim to perform unwanted actions, such as changing email address, changing password, transferring funds, and so on and so forth. For a CSRF attack to be possible, three key conditions must be met. Firstly, there must be a relevant action. So to enable a CSRF attack, there must be an action within the application that the attacker has a motive to trigger. This action could involve privileged operations, such as modifying permissions for other users, or any user-specific action, like altering their own password. Secondly, for a CSRF attack to work, the action should require one or more HTTP requests, and the application must rely only on session cookies to identify the user making those requests. There should be no additional mechanisms in place to track sessions or validate the user requests. And the third and final condition is absence of unpredictable request parameters. So the request responsible for carrying out the action must not contain any parameters with values that the attacker cannot determine or guess. For instance, if the attacker needs to know the existing password to make a user change their password, then this function is not vulnerable to CSRF. So this HTTP request satisfies all of the above conditions. The relevant action in this case is to change the user's email address. We can see that it uses cookie-based session handling because we don't see any additional authentication tokens or headers like authorization bearer. The only thing defined is the session cookie. Now this implies that the application relies solely on session cookies to identify the user making the requests. Third, there are no unpredictable values in the request that are difficult for an attacker to guess. Alright guys, enough with the theory. Let's go ahead and solve a CSRF lab on Portswigger. Alright guys, in this video we are going to solve a lab titled CSRF where token validation depends on request method. The lab description says the following. This lab's email change functionality is vulnerable to CSRF. It attempts to block CSRF attacks, but only applies defenses to certain types of requests. Alright? And our objective is to change the viewer's email address. So let's go ahead and launch the lab. As you can see, I've already logged in as Wiener Peter, and the default email address is wiener@normal-user.net. Alright? So the first thing we need to do is to get a hold of the post request that is responsible for changing this email address. So let's go ahead and do the following. Let's change the email address to, for instance, test@normal-user.net. So let's go ahead and update the email. And there you go, we can see a post request to the change email endpoint. This is the post request that we want to dig a little bit deeper in. So let's go ahead and send it to the repeater. Now, what are we seeing here? We are seeing a post request to the change email endpoint. We are seeing the new email address. And we are also seeing a CSRF token. Now, for those of you who don't know what a CSRF token is, a CSRF token is a unique secret code generated by the server side and shared with the client. So sensitive HTTP requests, which are actions that could lead to data modification, account changes, or other critical operations, should always include this token. When implemented correctly, the server will validate the request parameters containing the CSRF token and reject those that don't. So the first thing we want to verify is whether there is a token validation on the server side to begin with. Alright, so let's go ahead and change this value. So if we change the CSRF token, for instance adding an A here instead, and we send the request, there you go, we get a bad request back and it says invalid CSRF token. This of course indicates that there is a token validation on the server side. But what would happen if we would change the request method from post to get? Will we still have a token validation on the server side? Well, let's investigate. If we right click here and we select change request method, as you can see, now we have changed from post to get. And as you can also see here, the CSRF token is removed. All right, so let's go ahead and send this request and see what happens. So there you go, we did not get a bad request back. In fact, we got a 302 found. Now this indicates that the token validation is missing on the GET request. This is an opportunity for a hacker, of course. So let's go ahead and right click and let's maximize this one first. So let's go ahead and right click and send it to engagement tools, generate CSRF proof of concept. Let's maximize this one as well. And here we have the GET request, and based on that, the CSRF HTML that is generated. All right. So let's go ahead and change the email address to something else like silverhack@hacker.com, for instance. And we click on regenerate so that the value is reflected here. Yes, silverhack. And let's go ahead and click on test in browser. And we copy the link here and we proceed to, let's maximize this one. Paste. There you go. All right. As you can see, the email is changed to silverhack@hacker.com. And this means that by using a GET request to change the viewer's email address, we have effectively exploited a CSRF vulnerability stemming from the absence of CSRF token validation on the GET request. But to solve this lab on Portswigger, we need to go to exploit server, and then we need to copy the content of the CSRF proof of concept. So let's go ahead and copy HTML. Let's navigate back to the server and we input the content in the body. There you go. And then we click on store. And then lastly, we view the exploit. All right, guys. So as you can see, we get the same result here. We have changed the email address to silverhack@hacker.com. Alright guys, so that is going to be it for this video. I hope you have learned something valuable today. If you want to support this channel, you can like, subscribe and turn on the notification bell. And if you have any questions, please let me know in the comments section. So thanks for watching guys, and see you in the next one.